Salam and welcome everyone. So today we're going to be working on the question on the screen that says water is heated from 25 degrees Celsius to 35 degrees Celsius. By how much does its chemical potential change? The standard molar entropy of liquid water at 298 Kelvin is 69.9 joule per mole Kelvin. So the question is telling us that we have um water heated from 25 degrees to 35 degrees. So the first thing you do in any physical chemistry or science based question is that you have to write out the parameters. So we know the parameters for the initial temperature to be 25 degrees Celsius. We know the parameter for the final temperature to be 35 degrees Celsius. Then we're asked by how much does its chemical potential change. So basically, they're asking us for the change in chemical potential over time. So this is what they're actually asking us to solve. So they told us all of this information, but they also mentioned that the standard molar entropy of liquid water, so the standard molar entropy of liquid water, okay, is 69.9 joule per mole Kelvin at 298. Sorry, joule per mole Kelvin at 298 Kelvin temperature. So basically, they want us to find this. So for those of you who don't know, there's a formula that works for a question like this, and the formula is simply the change in chemical potential, right, is equal to negative the molar entropy, the standard molar entropy times the change in temperature. So this is the formula that we're supposed to use to solve a question like this. So we have the molar entropy, we have the initial temperature, and we have the final temperature. So all we have to do is to determine this. So basically the formula is just very, very direct. So next, we're going to determine the change in temperature. The next thing you have to do when you do that is just for us to remember change in temperature is just T final minus T initial. But we have our work in degrees Celsius. So we can do this in two ways. We can decide to do 35 degrees Celsius minus 25 degrees Celsius. That will give us 10 degrees Celsius. But this is since we know that to change from degrees Celsius to Kelvin, all you're doing is just adding a particular amount. This just simply means that if you subtract for temperature and get a change in temperature, you don't actually need to convert to Kelvin from degrees Celsius. You just end up having the same thing. So I'm going to stop talking now. I'm just going to explain it to you. Let me give you an example. You see T final, right? It is 35 degrees Celsius. We can make it to Kelvin by just adding 273.15. T final then becomes 35 plus 273.15, 308.15 Kelvin. So that's just the T final. Then you see the T initial. You have 25 degrees Celsius plus 273.15. So you end up here with 298.15 Kelvin. So T final minus T initial would be 308.15 Kelvin minus 298.15 Kelvin. So when you do this, you end up with 10.00 Kelvin. So this is basically the change in temperature. What I was trying to explain earlier to you is that since we have a situation where degrees Celsius to Kelvin, it is just adding a particular amount, which is 273.15 Kelvin. We don't actually have to go through the process of changing from degrees Celsius to Kelvin and then subtracting. We could have just simply done T final minus T initial. We just simply had 35 degrees minus 25 degrees is equal to 10 degrees Celsius. But since we already know that the unit conversion is not a multiplication or a division, it is just an addition, meaning if even if you take out the 273 or not is not really a big deal, right? It's just, and so you can just simply say 10 degrees Celsius is the same thing here as 10 Kelvins. But of course, because you're a chemist, it's better for you to do it through the first method where you write all of this information down. Anyways, we have that already. So changing chemical potential will end up being minus the molar entropy, which is 69.9 joule per mole Kelvin, times changing temperature, which we know to simply be 10.00 Kelvin. So 10.00 Kelvin. Of course, we're going to cancel out the units, and we end up having changing chemical potential negative 69.9 joule per mole times 10 would give you negative 699 joule per mole. So this is basically the answer to this question. You can see how easy it is. By the way, for those of you who don't know, this is a question from the Atkins Physical Chemistry 11th edition. This is chapter 4, and I have a bunch of questions that I've done on this particular book. So make sure you watch the playlist on my channel. If you're a student who is struggling in any of your STEM related courses, whether you're in middle school, high school, or college, I help students succeed in all your STEM related courses. So if you would like to book a session, or you would like to book continuous tutoring because you like how I teach online, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.